In this video, we'll try to understand what exactly is an index and how does index makes your search faster. So first, let's try to understand what is the goal of an index. The only goal of an index or the only purpose of an index is to make your search faster. So the next question is, how does actually index makes your search faster? Indexes makes your search faster, by creating something called as a B-tree structure or a balanced tree structure internally. So what we'll do first is, in this video, first let's go ahead and understand this theory of balanced tree structure, and then we will go ahead and see a practical demonstration of how actually indexes makes your search faster. Now before we go ahead and we start demonstrating things practically, let's first try to understand, how data is searched, when there are no indexes. So when you search data, which are not indexed, it searches sequentially. In other words, for example, you can see on this video here, if you want to search this value 50, the search engine has to, or the search engine, when I say the SQL search engine, it has to go and browse through all the records sequentially one by one until he reaches this 50 value. Now any lame person can easily identify that this will have performance hits. Why? Because if you want to search this value 50, you have to browse through approximately 49 records. So if you want to go and increase performance, or if you want to go and increase our search performance, then somehow we have to ensure that this scanning of all the records, somehow we have to go and minimize it. And that's what exactly B-tree structure or the balanced tree structure does. Now when you go and index some data, or when you go and index a column in SQL Server, what happens is it creates this B-tree structure internally. In the B-tree structure, right, the data is divided into root nodes, non-leaf nodes and leaf nodes. So you can see that how this data is divided over here. So you can see, like, at the root node we have 30 and 50, then in the non-leaf nodes we have 10, 29, we have 40, 50, and then in each one of these non-leaf nodes we have leaf nodes where we have actual data. Okay, so the leaf nodes actually point toward the actual data. Okay, now let's say that you want to go and search 50 here. Okay, so what will happen first is the search engine will start from the root node. So the first question search engine will ask is 50 equal to 30 or less than 30? Definitely 50 is not less than 30. So this complete tree over here will be bypassed, or this complete node with the non-leaf nodes and leaf nodes will be completely bypassed from the search. It will then go to the next node here and say, okay, is 50 equal to 50 or less than 50? Yes, this criteria meets. It goes again down below. It's again here in the non-leaf node, it says that, okay, is 50 less than 40? No. It again goes and bypasses this complete record scan from 31 to 39. And then it goes to 50 here, and here it goes and browses sequentially. That means it only goes and browses approximately 10 records until it reaches 50. So you can see over here that how cleverly, because of this root node and non-leaf nodes and leaf node arrangement, this complete record from 1 to 39 scanning has been bypassed. Now when the records are searched sequentially, that means without indexes, SQL Server calls this kind of searching as table scan. And when the records are searched by using the B-tree structure, it calls them as a index seek or a index scan. So now let's go ahead and demonstrate things practically. So you can see that I have a very simple database here called as Northwind, and it has a very simple table here called as orders. Now this orders table, let me go and select some records from this orders table here. So in this orders table you can see that we have some records here. We have records which has order ID, customer ID and employee ID. And now let's say that we want to go and search records by using the order ID. So what I'll do is I'll go and search a record, must be this Queen. Okay, so where order ID is equal to 11068. So this is a very simple search we have now. Now this orders table does not have indexes. So if I go here, right click, design, and if you see now currently we are doing the search on this order ID, right? So if you see this order ID here, it does not have any kind of index at this moment. Okay, so now the first thing we would like to detect is that, okay, so that means if it does not have indexes, that means this search of order ID is happening sequentially, right? That means it is using a table scan. So if you want to just go and see that if this search is really using a table scan, you can see at the right hand side there is a very small icon here, and this icon has this, when you move your mouse on this icon, it says that display estimated execution plan. So let me click on this. Now the time I click on this, you can see that it is telling, I'm going to use a table scan. A table scan means it will actually go and scan rows from the table. You can see if I move my mouse here, you can see the description here saying scan rows from this table. In other words, it will scan sequentially one by one record until it gets this record 11068. All right. Now, and also what we'll do is, let me just go and on all the statistics here. So I'm going to just go and on my statistics IO on. So with this statement, what happens is it will display all the statistics, performance statistics, when you go and execute this SQL. So one thing is sure that, okay, this is using a table scan and it scans rows one by one. And let me just go and see the statistics here. So you can see that it is doing, it is actually going and, doing three logical reads over here, right? So what I'll do is I'll go and copy paste this in a notepad, saying that when there was a table scan, it did actually three logical reads here, right? Now let's go ahead and create an index. So let's go ahead and go to this tables here, to this table here. Let's right click, go to indexes and keys. Now let's go ahead and add an index. So you can see that if you want to go and add an index, again I'll just show it. Right click on that column, order ID. Why on the order ID? Because currently we are searching on the order ID. So right click on the order ID column, go to indexes and keys and click on add. Now once you click on add, you can see that we have a nice column here saying that do you want a clustered index or a non-clustered index. So just say that yes, this type is an index, and currently we'll say okay, this is a clustered index. I'll later explain you that what exactly is a clustered and a non-clustered index. Okay, but first thing is, let's go ahead and see the benefits of indexes. So I'll just go and say okay, this is type index and this is a cluster index. I'm to go and close this now and save this, right? So now let's again go back to our SQL here and let's again go and see the display estimated execution plan. Now because we have created indexes, we expect something different over here, right? Previously we have seen a table scan, and now we should see something else here. So I'm going to go and click on the display estimated execution plan. Let me just go and remove this set statistic IO on because it's also going and displaying the plan for it. So let me again go and rerun it. So you can now see that he's not using the table scan anymore. He's actually using a clustered index seek. In other words, cluster index seek means it's going to go and scan a particular range of rows, rather than going and scanning what you call every row. Okay. So the first thing we can easily see over here is that the time we created a clustered index, it went ahead and it created a B tree structure, a balanced tree structure, and because it created a balanced tree structure, it actually is now scanning only a range of rows, rather than scanning all the rows. So that's the first thing. The second thing is, we would like to now go and enable the statistics here, and we would like to see that if there are any performance benefits, because if you remember right, when we ran this select statement without indexes, it was using three logical reads for reading the record. Okay, now if I go and execute this, and you can see now we have two logical reads. So this is, I know that the performance gain is not that much. What I mean to say is, still, there is a performance gain, right? And currently, my table has very less number of records. So that's why, we do not see too much big difference here. But in case you have large number of records, then you can easily see a big difference here in the logical reads. But said and done, we can still see, that when I did an index, right, it is only using two logical reads to reach to the record. And when I did not have index, it was going and scanning row by row. And you can see that it was doing three logical reads. So I hope that you enjoyed this video. In this video, we first, we tried to analyze that how index makes your search faster. We understood the concept of B tree structure, and then we later also demonstrated, how indexes actually makes your search faster. Now, this is only half side of the story. Indexes makes your search faster, but indexes slows down, or indexes decreases the performance of insert, update, and deletes, right? So in this video, I just covered the one part of the story that indexes makes your search faster, but there is the other part of the story that indexes they are not suitable when your tables are having high transactions of insert, update, and deletes. It can go and what you call decrease the performance if you have indexes. So what we'll do is, in the next part of the video, we'll try to understand how indexes are not suitable if your table are having high transactional data, or if your table is having high insert, updates, and delete queries. Thank you so much. Now, whatever video you have seen, right, is just a glimpse of what we have done. So, in case you are interested in our video package, you can go to our site, that is www.questpond.com. You can call on this number and you can ask the complete DVD package what we have. So, in this DVD package, what we have done is basically we have covered almost everything what a .NET developer wants. So right from basics of ASP.NET Object Programming, SQL Server, to new technologies like WCF, Silverlight, Link, Azure, Entity Framework. We also have UML, architecture, estimation, project management. There is a complete invoicing project end to end which is covered, so that you can get a better feel of how to actually create projects in a systematic manner. We have covered server products, both for SharePoint 2007 as well as for 2010. We have a lot of best practices video on SQL Server, etc. So this complete package, you can get from www.questpond.com if you're interested, and you can call on this number and you can ask for the rates. It's a very decent rate what we have. In the same way, as compared to the videos, we also have one more product with us, that is our interview question books. So we have different kinds of interview question books, right from .NET interview questions to SQL Server interview questions, SharePoint interview questions, BizTalk interview questions, etc. So in case you are interested in the books part, you can call on these numbers as per your location. So you can see these numbers on the board at this moment. So I hope that you keep enjoying the videos, you keep seeing our site, and I hope that you gain more knowledge. Thank you very much.